This talk is sponsored by IPFS and Filecoin. IPFS and the Filecoin Foundation are fully distributed open source organizations that aim to help radically improve the internet and drive breakthroughs in computing, which can help move humanity forward. Learn more at filecoin.io and ipfs.io.
An analysis of a good NFT contract based on the Cryptocommon smart contract. So hi, I'm Radik Sienkiewicz. I'm a senior UX conversion implementation consultant, currently transitioning into full-time Web3 development, and you can find me at velvetshark.com where I document my Web3 journey. So who is this talk for? So first of all, it's for smart contract developers, obviously, but also for smart contract learners, because there are a few very interesting tips and tricks, things that you can do with your smart contracts that you are usually not done, so a lot to learn here. Also, if you like witches, you will love Crypto Coven, so definitely tag along as well. So why is having good contract important? It's one and done. Once you deploy it, it's on the blockchain and there's no taking back. You cannot just go onto the server and edit it and fix it. For example, CryptoPunks, one of the most valuable NFT collections out there, and Crypto Coven that I'm reviewing as well. Both those NFT collections are version 2 actually. Both collections were deployed, and at some point there was a bug, and there's no fixing the bug. So both collections had to be deployed. So what we are seeing and what we are thinking is the main version 1. It's actually version 2, with version 1 being somewhere on the blockchain as well, just not being used. So why else is a good contract important? Gas savings. So both from the creator's point of view, when you create and launch and deploy your NFT collection, and from the users and traders' point of view, when you mint, when you list, when you trade the NFTs, all of that requires gas, and if it's optimized, everybody wins. Two other things, royalties and security. Royalties is what as an NFT creator, this is your livelihood. When it's being traded on the second market, you get royalties, so it's best for you to stay in control of that. And security, so that somebody down the line doesn't come and just drain whatever you have earned. So what is Crypto Coven? So Crypto Coven is a collection of 9,999 digital witches, which is not really the case, because it's 9,906 actually, but we'll see later on why. It was a bug in the contract, just a sneak peek. But it's also much more than just a profile picture NFT collection, because there is a story behind it, there are all the details, the consistency between everything, the story, art, even the smart contract, everything else. So a very, very interesting collection, and at every aspect, including the contract. So why is the contract awesome? Gas savings, I've mentioned already. Readability and simplicity, very well written code. Whitelist approach, different from what most NFTs do right now using Merkle Tree. No listing fees. So when you mint your witch, your NFT, and you want to sell it, you need to pay a fee to actually list it, to enable that collection to be listed. This contract has a function that you don't have to pay that fee. It's been pre-approved. And royalties is also handled interestingly. More on that later. So in the words of Crypto Coven witches, words are merely murmurs on the wind. So let's just see what the code does and how it looks. So the way it starts, I'll just go through the whole contract which you can find on Etherscan, wherever else. And it starts unapologetically on brand. You have a nice, historically cool ASCII word art Cryptocommon in large letters, and also it's both historical and modern because it uses the latest Solidity version 0.8. Further down the line, a bunch of imports from Open Zeppelin, industry standard. But what's interesting, both what is included and what is omitted from those imports. So ERC 721 is included, but not ERC 721 enumerable, which is what most of the NFT collections use. This is for gas savings, and it uses a different approach than enumerable. It doesn't make things easier, but it makes things more optimized. Another is IERC 2981, so that's for handling royalties, and Merkle proof for allow list claiming methods. More on that later as well. So just to give a little note here, there's a lot of code in this presentation, and I don't have a lot of time. I have a maximum of 20 minutes. So I will go briefly through all of that, but there's a lot of very interesting details here. So at the end, I'm also including the link to the presentation where I list all of those simple, small, maybe not that simple, but small details that that you can take a look later on. If I wanted and if I could go on for more than an hour on that, or even more. But as I have only 20 minutes, I will go briefly over all the functions, all the code. There is a lot of interesting tips and tricks to discuss, but if you want to look at all the details, you can find the presentation, the link to the presentation at the very end. So you can read it later and go through all the code yourself. So to start with, the modifiers, all the beautiful modifiers. So instead of just having logic included inside each and every function, most of that logic is just taken outside into modifiers, which makes the code clean, reusable, readable, and the functions using those modifiers are a thing of beauty, which we will see in a second. So this is the first and major function to mint. So one of the main things you can do with an NFT. You can mint it, and as you can, this is the whole function, and this is actually this is the whole code, one single loop, and it wouldn't be even a loop if you could just mint one token, one NFT, but you can mint up to 3. So that's why the loop is here. Everything else is modifiers. So you can see it now. The reentrant modifier is correct payment modifier, is public sale active, can you mint the witches, and do you have the maximum witches per wallet or not? All of that very clear, very understandable, put on top of that function as modifiers, and I think of beauty, what can I say? Another function is mint community sale. This one is a little bit more complex because this one needs to make a few more checks. So can you mint? Are you on the community sale list? And this uses Merkle proof. And you have your code that you generate. I think it was generated in the Discord channel, and then you come with that Merkle proof, and you enter it when minting, which is then verified with this function. A few more checks if you have no more than 3 witches, if there are witches left to mint, and it updates the number of community widgets in a mapping. So adds your address to that mapping so that you cannot mint anymore, and then actually mints. Another one is claim function. So Cryptocommon reserved 250 widgets for gifting to, I don't know, influencers or community members, or anyone else that they thought would need to have it, would want to have it, so they don't have to pay for it, they're just gifted it. So the claim is a function to actually take those widgets, to claim those widgets. Again, Merkle proof for verification that you're actually on that list, that you can mint and get that gifted widget. Max is at 250. It checks if you have claimed the widget already or not. And after claiming, it adds you to the mapping, which it actually compares against here. And then you can mint your widget safely. There's a bunch of different admin functions that I will not go through because they are pretty self-explanatory and they just usually do one thing, and that's it, used for modifiers. So set base URI, so this is for IPFS. Everything else is pretty self-explanatory. Set verification hash, is public sale active or not? Is community sale active or not? Set the Merkle roots for a community list and for claim list, both mentioned already, reserved for gifting. And the last one is also interesting. So as I mentioned previously, this is version 2 of the contract. In version 1 of the contract, there were 128 widgets minted before the contract broke. So this function actually takes those 128 widgets and moves those to the new contract so that those who minted those do not have to do it again. So now what broke in version 1 of the contract? So this is an interesting one because we can learn from this. The gift widgets function was at fault. So this is the function from version 1 of the contract. So this is the faulty function. And this is where the actual error occurred. So what it was doing? It was doing that gift widgets, an array of addresses. It takes an array of addresses to gift to, and it checks if the number of gifted widgets. Yeah, so the requirement is that you cannot have more than 3 widgets per wallet. So this requirement here is it checks if you can even get that widget. So if you already had 3 widgets in your wallet, the gift widgets function just skips you because 3 is the maximum that you can have per wallet. So it checks if you have 3. If you do, then it skips. It doesn't give you that widget. And that is actually what eventually broke this. So it checks that requirement, and then it mints those. It gives those widgets. So it takes that array of addresses, and one by one it checks if that address has the maximum amount of widgets or not, and then mints. But let's see what it does and how it does it. So it takes, let's say the array has 3 addresses. This loop has 3 addresses in the array. So the second address, let's say, has 3 maximum widgets. So at the first pass of this loop, I is 0. Address has less than 3 widgets, so we can mint. We can gift the widget. So this is how the safe mint function, safe mint call here looks like. Let's say total supply is at 100. So total supply to this address plus 0 plus 1. So I is 0 for this loop. And total supply, this is to actually generate the token ID. So what's the token ID of this switch? So at the first pass, it means a which with a token address 101 to this address. Fine. We go to the second loop. And the second loop, we have that address that already has 3 witches in the wallet. So what it does, it skips this one because it fails here. It fails this requirement if balance of addresses has less than maximum witches per wallet. It does not. It has the maximum witches per wallet, so it does nothing. And then the third address, third wallet, what it does is I is now 2, 0, 1, and 2. Address has less than 3, so we can mint. So what it does is it takes total supply, which is 100. It adds 2, this is I from the loop, and it adds 1 to it. So actually, if all the wallets had less than maximum amount of witches, it would be 3 means of address, token ID 101, token ID 102, and token ID 103. But one skipped, and we have token ID 101 and token ID 103. What happens? So those are minted. This is fine. This function worked. But then when someone next comes and wants to mint, so this is what the minting function looks like. So take the sender's address, take the total supply, and add 1 to it, and that's the token ID. But total supply at this point is actually 102, not 103, because 1 has been skipped here through gifting. So it takes 102. This is the total supply, and it adds 1 to it. So actually the token ID is 103, and it tries to mint a witch with token ID 103, but it's already been minted here, and the contract breaks. So that's how version 1 of the contract stopped working, because you cannot mint with the same token ID. And at 128 witches, this happened. The contract stopped working. So how can we fix this? So on the left, this is the old function that we have just reviewed, and this is how it looks now in the new contract. So first of all, this function was split in 2. So the logic was moved into the modifier. So now it looks much more elegant. So only owner can gift witches, and instead of let's just look here in more detail. So instead of just taking total supply, adding I, which is the iterator, and adding 1 to it, which is not safe to do, there's a next token ID function, which would never skip a number and is only assigned the correct token ID, and it works only when actually the witch is minted or gifted. So it doesn't skip any numbers, it doesn't skip any token IDs, and that's a simple fix for this function. So that's the current version of the contract. It works, everything is fine. So look out for that total supply. But there is another bug in the contract, and it's actually with gifted witches again. So remember, I said that it was supposed to be 9,999 witches, but it's actually 9,906. This is the reason why. So what was happening? First of all, let's see what was initialized. Max witches was at 9,999, and as I mentioned also before, the team decided that they will have 250 witches to gift to whoever they want to. And this is the modifier, one of the modifiers, can mint witches. So what it takes the token counter number, so how many witches have already been minted. It takes how many witches you want to mint. Could be from 1, 2, or 3. 3 is the maximum. And it looks if it's smaller than max witches, which is 9999, minus 250. Because you cannot mint those 250. So the maximum that you could buy on the market was 1,749. So this minus this. So this modifier was looking if it's less than 1,749. If it is, then it mints. But while the sale was happening, while people were minting, the team was actually gifting the witches. I don't know if you already see the problem or not, or maybe you read through the rest of the slide already. So the team was already gifting the witches. So what happens when team gifts the witches while the sale is happening? So let's say the team gifted. So yeah, let's say what happened in reality. While the sale was happening, the team gifted 93 witches out of those 250. And when the counter reached 1,749, which is here, you could no longer mint. But it doesn't mean that 9,749 witches were sold, which was the intention of the team of Cryptocommon, and to have this number at the end. So this is the number that they wanted to sell, but it's the number of what they sold, including 93 witches that they already gifted. At this point, this modifier, when you tried to buy, didn't allow to buy any more witches. And because this max gifted witches was also hard-coded at 250, they could not increase the number of gifted witches as well. So they ended up with 9,906 witches in total instead of 9,999, and that's it. So how to fix it? There's an easy fix. You need to make this one. If you want to gift while people are buying, you need to make this the right side of equation dynamic. So whenever someone is gifted a witch, you need to increase this right side of equation by 1. This way, this side of equation at this point, 9749, would be larger by 93. So 93 more witches could have been bought, and they would end up with 9999 witches in total. So that's a simple fix for that. This is the current version of the contract, so there will not be a new one. So it's actually, this is how many witches they have ended up with, 9906, and that's it. 2 more functions to withdraw. So these are pretty standard, pretty self-explanatory. You can, when someone pays you, buys your witches and pays you, or when you get your royalties, you actually need to be able to withdraw those functions to your wallet to be paid for your work. So this is the first function to get the ETH. So address this balance. You get all the balance of ETH that the contract has and transfer it to your wallet, and it's only owner, so actually it prevents anybody else from doing that. Well, you also can withdraw tokens, not just ETH. That's the second function here. Another one function that I mentioned already is zero gas. So when you have a witch, when you have an NFT and you want to sell it on OpenSea, for example, what you have to do is you need to initialize that specific collection. So even if you have 10 witches, for example, you initialize only once. You initialize the collection and then you can start selling that. But it can be prevented in the smart contract by the NFT creator that the whole collection is already pre-approved, pre-initialized. So when you want to list your NFT, when you want to sell it, you don't actually need to pay gas. So it's building goodwill for those who want to sell it. It's creating them savings. Another interesting thing is how Cryptocurrent treats royalties. Instead of platform specific that OpenSea, for example, provides, they have a specific EIP 2981 standard, which could be helpful further down the line when OpenSea is no longer the de facto monopoly that it is right now, and when trading elsewhere will be more common, or when you actually want to update your royalties or do some more fancy stuff with it further down the line. But another bug in the current contract that what they have done is the return of this function, what it returned is the address of the receiver, so who will receive that amount of royalty and royalty amount. So in their case, it's 5%. So it's your sale price times 5 times 100 with safe math. But yeah, remember the Crypto Coven uses the latest 0.8 solidity version. But as of solidity 0.6, smart contract cannot receive ETH directly without implementing a receive function. So if there is no receive function, you cannot send ETH to that contract. But that was already live, but because of thanks to royalty registry, Cryptocommon could override the receiver address. So so this receiver is the address of this contract, of the Cryptocommon contract. So they overrode it to be a receiver, a different address of a different wallet, and they could save the royalty this way. Otherwise, they would probably be stuck with no royalties and they would probably need to relaunch the contract. And there is a simple fix for that. There's just like one liner that you add to be able to receive ETH to your contract, which is receive external payable. That's it. Very simple fix. So what did Cryptocommon nail? What they could have done better? They nailed readability and simplicity. They nailed gas savings, building goodwill, whitelist approach, and the interesting one, which is becoming more and more common now in the industry, but it wasn't when they launched it. No listing fees, royalties, and what they could have done better, gifting widgets. So 2 bugs in 2 versions of the contract could have been handled better. Royalties configuration, they saved their ass with that, but it's a simple thing that they needed to keep in mind. Another one that I haven't mentioned before is that they could have stored all the art on IPFS. Currently, they only store the metadata on the IPFS, but all the art, those beautiful widgets that they have, is stored on the Amazon's AWS servers. If those goes down, or if they stop paying, or if anything happens, all the NFT collection can break. But they have a way to fix that. They have the base URL function that they can update it. So in the future, they can go to IPFS eventually. But they may or may not do that if needed. key points to remember, that's more of a summary for you to get back to and to maybe learn from. Merkle proof, royalties, pre-approved, total supply, to be careful with it. So if you're working on your version of smart contract, keep those in mind. Have a look how they did that. Have a look at those modifiers, think of beauty, and try to do it yourself. So this picture was worth 1,000 words, which probably a million. This is my witch. I have bought that. I own this NFT. This is her name, and this is actually also what the Cryptocurrent is doing differently. Every witch has a name. Usually NFTs have just the numbers, like NFT number 5,525. Cryptocurrent witches all have their names, like all 9,906 have unique names. Mine is the binary scroll. Sources and acknowledgements. So I went through the current and old contract, analyzing it step by step. Also, the Cryptocommon smart contract developer, Xianu, was invaluable in helping. So I contacted her on Twitter. We had a chat. She was very helpful in replying to everything or clarifying all the questions that I had. So thanks a lot for that. And a few more sources, as a Twitter thread, Cryptocommon contract bugs, article also by Xianu. And this is the link to this presentation for you to go through all the code to take a look in more detail. So thanks, let's get in touch. This is where you can find me, velvetchart.com, Twitter handle, my email. Thanks a lot.